Welcome back. Problem 3, section 4.3. Find the derivative of this. So notice we like to say derivative of an integration is the object inside, but the limits are not the same. Yeah, you need a lower limit to be a number, upper limit to be the same x. Well, neither of that is true. So how do we work with this? In your problem, you will find a hint. You can look at it, but I've used it. So let's complete this problem. So the question is gx is integral 3x to 6x u plus 9 over u minus 4 du. This is a slightly difficult problem because there is the lower limit should be a pure number. It isn't. Upper limit should be x. It isn't. Okay, so they are both problematic. So how do we understand this? Well, think of it, split this through some number of your liking. You can choose 1, 10, whatever. I chose 0. This integral is same as integral from 3x to 0 and 0 to 6x plus. So 3x to 0 plus 0 to 6x of the same thing. You can always split an integral because splitting an integral is splitting an area. So you can take any number you like and split it along the way. Okay. So first part 3x to 0, I'll call it fx. Second part 0 to 6x, I'll call it hx. So derivative of g will be derivative of f plus derivative of h. So it's enough to understand these two separately. Let's start with this because its lower limit is a fixed number. This one will have to do a little more. So let's work with hx first. Hx is 0 to 6x. Now, let me use substitution. Let's call w to be 6x. Okay. So, if this had been x alone, we would have been done. Its derivative is the object inside. It is not simply x. So, you have something else, 6x. Let's call it a new variable w. Then hx is integral 0 to w of the object inside. Okay. Now, I want to take derivative of h with respect to x. Here is where chain rule comes in. Okay. So, this is chain rule. I'm using chain rule. What is the chain rule? Derivative with respect to x is derivative with respect to some other variable and then derivative of that variable with respect to x. This is chain rule. So why did I choose? I could have chosen any other variable, but I am choosing w because that's the one I used. Now, if I look at derivative of h with respect to w, now this looks like perfect. Lower limit is a number, upper limit is the w I want. So its derivative with respect to w is the object inside. I have to replace my variable with w though. Okay, I did that. Times by chain rule derivative of w. W was 6x, so its derivative is 6. Okay, my question was in x, right? So my answer should be in x. W is 6x, so it is 6x plus 9. You see where I see w, I place 6x. Where I see w, I place 6x and there is a 6 outside. Okay. So this is using chain rule. So that was the first part for hx. Now let's play with fx. Same approach. Fx though had a lower limit of 3x, upper limit of 0. Well, how do we interchange? We can always interchange. But when we interchange, you get a negative. Okay. So negative integral 0 to 3x u plus 9 u minus 4. So this is very good, except I need an x here or one variable here. So let me call that variable w again. W is 3x. So now f is minus integral 0 to w u plus 9 u minus 4. So notice this is with respect to x. If I take derivative with respect to x, I go via a chain. First I take derivative with respect to w, write my function as a function of w, times derivative of w with respect to x. Well, this part is easy. W is 3x, so derivative is 3. Whereas this guy, now I use fundamental theorem of calculus because I have pure number on the bottom and my chosen variable on the top. So that becomes, I replace the u by the w, everything. So don't forget the negative. W plus 9, W minus 4. My question was in X, so don't forget to replace the W with the X expression. W is 3X, so negative 3X plus 9, 3X minus 4, and this particular 3. So G is all of this. Derivative of F with respect to X plus derivative of H with respect to X. All right, so this is my final answer. Let me write this. You have to be careful when you write it. So I'll write it like this, minus 3. So that's a minus, that's the first one. I have a fraction and then I'm multiplying by 3 plus I have a fraction and then times I'm multiplying by 6. Okay, so make sure fractions are separated out carefully. Now the first fraction upstairs is 3x plus 9, downstairs is 3x minus 4. Here upstairs is 6x plus 9, downstairs is 6x minus 4. All right, submit. We are good. Until next problem.